And now we've come to the portion of the presentation where we will demonstrate the actual FactoryLogix product. And in order to do that, we're going to take 30 to 40 minutes to demonstrate the full scope of what it could do in your manufacturing enterprise if deployed in its full manner. But in order to make the presentation of the product understandable and meaningful, we've come up with a scenario where FactoryLogix will be applied across 3 different fictitious companies that are focused on building different types of products along the value chain, from piece parts up to PCB and box build, and then to subassembly manufacturing in a different company, and then final assembly in the final company at the top. And we'll get into a little bit about the nature of these companies in a moment, but we will be ultimately constructing that robot arm shown on the screen right now. And it will show how across 3 different companies, subassemblies come together, ship to another factory, and are integrated, and all the ways that FactoryLogix would support this model. So moving to these fictitious companies that I mentioned, the first is Motodyne. They're a system integrator that is focused on larger scale manufacturing of subassemblies that arrive to their factory to make the final product. They don't have a lot of automation. It's a highly skilled environment, and validation of the final assembly steps and traceability is important to them. The next company is Drive Technique. They are a German company that's focused on drive and servo assemblies. They have a medium level of automation, and their assemblers are very skilled, and repeatability of the process is highly important to them for quality reasons. Lower in the value chain is the EMS provider, Rapid Circuits. They're a PCB and box build, higher volume manufacturer in Mexico, and they have high automation, obviously, for circuit card. No automation in box build, and they have quite a bit of turnover in their labor force, requiring a high level of operator support. As we go through the presentation, we're going to be coming back to this solution overview that you've seen before in the business presentation, but we're only going to be using this as a placeholder. As we move through the demonstration of the product itself, we'll come back to here to discuss a certain area of the solution as we move through. We're going to begin the demonstration with the manufacturing execution interface that would actually be used on the shop floor. The FactoryLogix system design was intended to provide shop floor operators all the information they could possibly need in order to do their job effectively and efficiently with a single scan. So with one scan of the unit in front of them, if they're in a serialized operation, is that it presents to the operator a configured GUI that's laid out in a manner that's appropriate to them. So as simple or as intense as the manufacturing engineers wished. It brings up the right revision of the document set that they should be seeing. It knows where they're standing physically, so it brings up the right documents for that location in the route. It knows the right operator, their certifications. It confirms whether they have the right tooling in front of them, as well as the chemicals and the parts and absolutely everything they require. And it does not add any ergonomic or transactional overhead to what they would be doing anyway. And yet, as a result of the activities, the natural byproduct of what they're doing, the business gets what it needs without the operator even realizing that's occurring. All the trace, the control, the visibility, the enforcement of the route is simply a natural byproduct of running the system. So there is no additional transactional overhead. So if we can move on to the demonstration and show you what the experience, if you can just imagine now we're an operator on the shop floor, and the product moves in front of the operator, and they simply scan it. So as we can see in this interface here, imagine for a moment that you are the operator in the box assembly area of Rapid Circuits in Mexico. The visual aid that you see in front of you has a video of the assembly operation itself, and of course other systems can provide that as well, or a JPEG or something of that sort. But what I'd like to direct your attention to is actually surrounding the visual instructions, because there's something very unique about FactoryLogix in that regard. The content that you're seeing in this view is dynamic. So at the left, we have the steps and activities and the confirmation steps and so forth. But below it, you have a bill of materials block that's color-coded. And you notice the colors link to the bounding rectangles around the parts themselves. This is not typed in by a manufacturing engineer at some time. These entries are actually dynamically linked to the bill of materials. So the database upon which FactoryLogix sits is actually adaptively linked to these entries. And that automation goes further. That drawing header at the bottom was actually engineered in the manufacturing engineering tool. It's a collection of rectangles and JPEGs and so forth, but the text entries in large part are also dynamically linked to the database of FactoryLogix. Now, why is this important? It's important that, one, it expedites the development of the visual aid initially, because most of the content is actually automatically being populated by the system. But where it becomes even more valuable is when there is a deviation or an uprev. When there's a revision change to this document set, of which there might be 50 stations that are documented. In a traditional system, you would have to go into all 50 stations and documents and make sure that every rev and every entry and every BOM element is updated manually. And inevitably, there'll be a mistake made across those 50 documents. There is no such situation in FactoryLogix. Uprevving a document, broadcast the changes adaptively through every single one of the views automatically, and you're back out to the floor in what could be minutes instead of hours. Now, in addition, visual aids and work instructions are not the only thing an operator needs in order to do their job properly. All companies, all manufacturing companies have supporting documentation such as standard practice instructions on how to use Loctite, or the specifications for a tool or a chemical, or in this case, say the operator thinks there's something wrong with that housing and needs to actually get the spec control drawing for that plastic injection molding and measure. They can just instantly go to the document vault that FactoryLogix presents to them at the left, the upper left there with the 5 on it, indicating that there are 5 additional documents that were not developed inside FactoryLogix, but FactoryLogix is acting as the vault to present it at the point of use where it would be most needed by an operator. So now we were at Rapid Circuits. Now imagine that electronic and box assembly has gone out to the loading dock, and it's a shipping dock, and it's on its way up to Motodyne. That's the system integrator that builds the entire robot arm, and they have to incorporate that. So now imagine we're up at Motodyne in Northwest United States, and we are now an assembly operator in a very different type of factory. And you might note the user interface on the FactoryLogix shop floor portal is entirely different for this particular type of assembly. They're moving large objects around that have to mate together, and they have to confirm that a subassembly is the appropriate one to be docked into an upper level assembly, in this case that upper arm into the middle arm. So the operator is guided with the video, of course, and some interactive instructions with the highlighted area, and they're guided through the scanning of one unit into another, which generates the hierarchy of the traceability, of course. In addition, this operator is being asked to confirm the actual tool, the torque driver in this case, that they used to fasten the 2 parts together. But further, once the proper tool has been confirmed, it guides them through the torquing operation, and further still, the actual unconventional nature of that torque pattern, which one would think would be a cross torque, but in this case they specifically want it to go around the circumference of the flange. So the system is doing a lot for this operator, making sure they're doing the right pattern. It's confirming that the torque values coming from the electronic driver electronically into our system via an IoT connection is all correct and within tolerance. And without the operator knowing it, the entire device history record and all the traceability is being compiled in the background. Now we're moving on to the FactoryLogix QMS system. The approach of FactoryLogix to helping a company get to world-class quality was engineered such that it helps you tackle what we believe to be the three main obstacles to getting to that level of quality on one platform. The first area of the QMS system involves firewalling the manufacturing enterprise from quality issues related to non-conforming material coming in through the loading docks, so supplied material quality. And in that area, FactoryLogix excels because it handles the issue of the fact that most companies are either oversampling incoming material or undersampling, because the overhead involved in adaptively tweaking your sampling rates based on supplier performance in the past is very hard to manually do. And also, all the overhead of finding the right inspection documents, knowing what the key inspection criteria even are, a lot of overhead involved in all of that. FactoryLogix, we're going to show how it overcomes those primary problems in the incoming material docs. The next area is the issue of variability in process or test that results in a nonconformance as you're manufacturing the process. So this involves a lot of aspects: detection, identification, repair, and recovery from defects found from test or during the course of the process. The logging the nonconformances in a visual manner, which we're going to show you, and the test and AOI data acquisition as well. So everything involving quality issues found while the production is actually going on. But when one considers those two aspects, they are preventing a problem from getting out to the customer. Those two things I already discussed, the IQC and the in-process inspection and repair. But how do you make the enterprise better over time, and how do you document all of this for auditors? And that is where our administrative quality system comes in. And this is the system that envelops everything about what happens in FactoryLogix from a quality perspective, but it brings digital automation to the laborious and tedious sometimes processes involved in material review boards, corrective action, preventive action, and so forth. The business's reaction to nonconformances that happen in the other areas. And we're going to show you how FactoryLogix makes that simple and fully reportable. And now we'll go into the FactoryLogix quality system itself. So as with all other areas of the shop floor experience for an operator, in this case an inspection operator, they need only scan the ID of the product, and everything required to do their work comes up in the FactoryLogix interface, as you see here. And also, this interface does not appear quite like the other ones that we've seen in the prior demonstrations. It's been laid out by quality or manufacturing engineering for the specific purpose of inspection of a mechanical drive, which is depicted here. Now, unlike other quality systems that expect operators to log nonconformances and defects and so forth in forms, edit boxes, possibly drop-down combo boxes, FactoryLogix enables the placement of the product image itself associated to the parts. The mere act of clicking on the part, as done here, opens a defect code list. Now, this is not just the master defect code list of the company. It's filtered by this point in the assembly process. So the only defect codes that are presented to the operator are ones that are appropriate. For example, if the coding of the drive has not actually occurred, coding at this point in the process, coding-related defects simply won't be presented, which expedites data logging and eliminates erroneous defect input. Another advantage of having the actual visual upon which to log the defects is that you can put geographical defects down, such as was done there. There's a housing dent or a ding or a scuff or something of that nature, and it was logged, which allows you to then later look at actually, well, where was that problem when rework, repair, or possibly like an MRB meeting occurs. But as you notice at the bottom, the act of logging those defects so simply is generating a good deal of data that the operator did not, in fact, have to log themselves. So that macro at the bottom is the list of all the nonconformances that are being collected with all the details associated to it, and there wasn't a single use of the keyboard to do that. In addition to the view we just saw upon which defects can be collected, let us suppose that the operator needs to examine the product in greater detail. They can go to the supplemental documents button at the upper left and bring up the actual 3D model of the product and expand it, make it transparent, examine it in greater detail, and then go back to the other view in order to log the defects. If there was some detail that they required, and of course spec control drawings and things of that nature could also be brought up at this time. Now let us imagine that we are no longer at Drive Technique, the drive manufacturer in Germany. Now we are back at Rapid Circuits in Mexico, where the circuit cards and the box build was being done. And again, we are a line operator scanning a unit that's in front of them. But we're going to show this because it shows that when in a circuit card environment that is actually from a data perspective an even more difficult data logging and defect logging challenge, FactoryLogix shines because it is aware of the ECAD design itself. With systems other than FactoryLogix, collecting quality against a circuit card is, again, forms and data entry. And how could an operator be expected to know what pin number on a 132-pin device is actually the one that has a cold solder joint on it? None of that is a problem with FactoryLogix. As seen here, the simple act of dragging a rectangle around the offending pins, indicating the defect type, and clicking OK will generate a massive amount of absolutely accurate data about those defect types, the connection points, the pins, the footprint, the package, everything. Imagine logging that manually in another system. It would be, one, either not done or highly unlikely to be accurate at all. And it would take a great deal of time, but with FactoryLogix, it takes very little time. But there's also another benefit beyond the accuracy and the depth of the data. It's the geometric or positional nature of the data that's being logged. Whether it comes from a human or an optical inspector, it's the same. The benefit of that is that in circuit cards, defects are often positionally related. So there could be a striping effect across the board, or a certain area due to a design problem of component spacing. There's a high concentration of defects occurring. The fact that data is logged against the product design itself in FactoryLogix enables what we call Doppler radar for quality here, where you can actually see the frequency of defects within locations and color code the surface of the product to do an even greater level of quality analytics. Now, as this logging is going on, let's imagine that in this environment at Rapid Circuits, quality engineering or manufacturing engineering had set a threshold of this particular type of defect that, should it occur, it actually justifies a much greater business reaction to that problem, such as sending it through a material review board, a corrective action, assigning preventive action, and so forth. So what occurs as a result of that logging is an email just went out, and it informed possibly a large group of people that we have to do something about this in terms of correcting the business to ensure it does not occur again. Now, this list, I'd like you to mentally allow me to take you away from the shop floor. This is more in the quality offices, the business offices, the engineering offices of the factory. This is the master list of all the nonconformances that were automatically spawned from the process or incoming inspection that are now going through the automatic workflow governed by FactoryLogix to bring all those who need to be involved into a step-by-step process to complete the corrective action. So what we're seeing here is a largely completed CAPA that has gone from being spawned on the floor or wherever, the decisions regarding its disposition, containment. The list at the left shows you what it went through in this particular case, all the associated documents, the notes of those who were involved, the sign-off records, the containment plan that was generated to make sure that the affected products were all contained and the disposition of them was handled properly. And then, of course, the decisions made by the company, the groups involved in this, on what the root cause was, and then the action plans. And then eventually the effectiveness of those action plans will be checked in the future and logged. Now, while this is a benefit in helping put the company on digital rails that take them through these rather complicated processes of material review boards and corrective actions and so forth that often involve a lot of people and approvals that it all governs. It takes that clerical minutia that's prone to risk out of the process. But another great benefit of it is in the data that it yields. The actions that are all taking place through FactoryLogix in the administrative quality area that we're seeing in front of us here automatically, as a natural course of their operation, generate all the audit logging, the AS9100 reports, everything an auditor or even a customer could possibly want to see about how this company actually manages quality on the business side as a reaction to things happening in production, and how it is the QMS system is being used to actually improve quality over time, not just react to issues that occur. Now we'll move ahead to the incoming material quality element of the FactoryLogix QMS solution. So this IQC area, what we just saw there was the list of good receipts notes for, say, material coming into the loading dock. And now I'd ask you to imagine that you are an incoming quality inspector somewhere near the warehouse or the loading docks or somewhere around there in the enterprise. And the simple act of selecting the GRN that was assigned by ERP of these incoming materials automatically launches this user environment you see. So this would come up in front of the inspection operator in the warehouse, and at left you see the key inspection criteria for this particular part. It guides them through those inspections. In this case, there's a radii need to be measured, and it will check whether they're in tolerance, and then the shaft length and so forth. But what you might notice at the right is you can develop essentially what are visual work instructions for the act of inspection as detailed as you'd like. All the power that you saw in the shop floor production documentation engine of FactoryLogix is available here as well. So as you can see, it becomes interactive. You click on the next step, the arrows and the pointers change exactly what they need to do to inspect this product. Also, should the operator want more than these visual work instructions, should the inspector want that, the supplemental documents, in this case the actual vendor's spec control documentation comes up, so if they need to dig into even more detail about what to inspect or what the limits are, they can do that as well. But what the inspector doesn't even need to worry about in the background is the issue of the sample size. FactoryLogix active rules engine is running in the background, running the algorithm that was selected by the quality or manufacturing engineers for this particular product. And in this case, the batch size is 20, and it's indicating that only 5 need be sampled. Now, there could be, depending on the configuration the customer chose, if a single one fails of that sample, it could be programmed to fail the entire incoming lot, or it could tighten up the sampling, increase the sampling rate. All manner of things can be done automatically, but the beauty of it is those doing the inspection do not need to worry about it. It fully automates it, and it enables them to sample as little as is prudent within the switching plans that were assigned by engineering that the inspectors probably don't even know about. So if we for a moment go over those sampling plans to give a little more color to that, this is the user environment used by quality or engineering to actually set up the plans. This generally accepted ones, some mill standard ones, squigglier rules are loaded in there, but then they are highly adjustable within them. You can see that the depth of options and switching rules that can be applied to a given incoming inspection is rather deep and sophisticated. But the objective from a business perspective is to inspect enough to ensure high quality, but not over inspect, which is a waste of money and time. The next area we come to involves FactoryLogix lean materials management. And the design intent of this area of this system is to resolve a classic conflict that occurs in most manufacturing enterprises between finance and purchasing and operations. And that conflict relates to the fact that operations management wants to keep production moving as efficiently as it can, asset utilization maximized as much as possible. And in order to do that, in many cases, what fights that goal of theirs is they run out of materials. They have material shortages. So the response to that is a desire to have more materials on hand than really technically is required. So that's operations goal in order to keep their lines running. But then you have finance and purchasing. For very real business and financial reasons, you want to have as little inventory on hand as possible to meet the goals of the factory. But those two things, those two goals of those groups run in conflict with each other because, frankly, of the way that ERP typically handles material, which is push-based out from the warehouses to the floor. FactoryLogix addresses this in a very different way and solves that conflict by implementing a pull-based material control system where and it can do this because it is aware of where all the detailed lowest level of component delivery materials are at each location and on each asset in the factory, knowing the real-time consumption data, not inferred or calculated consumption, the actual consumption of the materials on the floor, and all the asset information as to the run rate, the predicted times that the jobs will be over, units will be completed through a given machine, and so forth. By taking all that data and also understanding the operating hours of the warehouse and how long it takes to get materials from the warehouse to local stores and out to the lines, FactoryLogix combines all that information and it generates a pull model where it's ensuring that lines are up and never down for material shortage reasons, and yet there's never any more material being pulled from the warehouse than is absolutely needed. So both finance and operations achieve what they need to achieve, but FactoryLogix makes it possible. And we can't really demonstrate this entire solution because we don't have a factory right now, but what we can show you is an element of it, which is our materials logistics interface, which in this case is represented on a mobile scanning device, and the HTML5 interface is displayed here. And what the operators moving around the warehouse would see is this user interface, and they are constantly getting refreshed what we call transport orders, which is what should be pulled and the destination to which it should be sent. So it guides them through the material kitting and the transportation to individual locations in the factory floor or local material stores or what have you. So this interface is being used by many operators in the warehouse, and it's a pull-based drive of materials from warehouse out to the floor, ensuring that balance of utilization and minimization of materials is achieved. Now we come to how FactoryLogix supports regulatory and customer compliance. Now, any company that either has significant customer demands for trace and just all manner of data, or is involved in an industry or a vertical that has regulatory demands like defense and aerospace and safety requirements in automotive and so forth, or medical, you are already achieving these deliverables in terms of data and reporting to whomever is demanding them. So you wouldn't be able to function as a business if you weren't. So it isn't as if FactoryLogix is doing something that you don't already do. It's a matter of how accurately, easily, and cost effectively and simply it achieves it. And that's where FactoryLogix really can add value in the manufacturing enterprise by making all of your audit support, your certificates of conformance and compliance documentation a matter of a simple click, even to the level of shipping with a lot of these documents, which we're about to show you.
In keeping with the customer compliance and regulatory industries that require such reports, FactoryLogix, as a natural fallout of everything that you've seen so far, FactoryLogix will actually generate some of these reports that I'm about to show you right now. For instance, this DHR or device history report which is a rather comprehensive as-built device history report showing the route steps and operations that this particular unit traveled through on its way to completion and the status as it went through. All of the traceable subassemblies that were joined into this upper-level assembly. And taking that further, we have some of our AS9100 style reports. These reports, this particular one for receiving and inspection, speaks to an IQC process where we sampled 12 pieces from a 50-piece lot and performed certain measurements and tests. Product test as well, the actual product we were speaking of during our QMS portion of the demonstration. We spoke about inspections that can be performed in an automated fashion or manually. Again, as a natural fallout of just using FactoryLogix, all of this information and these types of reports can be generated, and in fact, they can be generated automatically. Once an assembly or a device reaches a certain point in the route, these reports and outputs can be generated automatically and included with the traceability data that's provided to the customer. So I think it's important to point out that all of these reports are simply included during a normal deployment of the FactoryLogix software.
We now come to FactoryLogix Adaptive Planning Engine. Now, planning in manufacturing is one of those words. The word planning is, if it's said to 150 manufacturing professionals, there'll be 150 different opinions as to what planning is. So it's important that I frame where this module in FactoryLogix fits in the grand scheme of the issue of planning. ERP and other systems that bolt to ERP are varied and many of them available, and they're very good for long-term planning. That's ERP is connected to the supply chain information and many other things, and it is very good for long-term planning. But where those tools typically stop in terms of the depth of their capability is that they are not connected to the detailed information about the real-time asset run rates, detailed material location and attrition rates, everything that's happening on the shop floor, the line availability at the moment. All of those important elements are often not available to the upper level planning systems. So they are not good at responding to changing immediate demands, like within an hour range or maybe even 5 days or a week or so forth. That's where the FactoryLogix Adaptive Planning tool comes in, to accommodate and assist in the planning that is a result of all the things you can't predict that tend to happen in manufacturing, especially in high mix-up manufacturing, almost every day. So what we're about to show you is, if you imagine you're a floor expediter or a production planner, and you had a scenario occur where you came in, you had your ERP plan, you had your general plan for the week, but a program manager who was talking to a customer ran in a panic and said, we absolutely have to jam this customer's production order in today somehow as best we can. And that's the challenge you suddenly have after you had your coffee, and we're going to show you how our tool would make that more expeditious and effective to implement.
So now, taking the role of a production planner at Rapid Circuits, as Jason just pointed out, I'm now being faced with a scenario where a program manager has come running in and I now need to jam a new production order into my schedule. What you're seeing on the screen right now in the form of these swim lane diagrams are my individual work cells or production lines out on the factory floor. You can see that I have a couple of surface mount lines, a through-hole line, a cable harness assembly line, and so on. And what I can see here at a glance is that I have a particular surface mount line in use right now, the red bar indicating that it is running over its allotted time, but I do have some availability on this second line. So over here on the left-hand side is a list of all of the batches that I currently have outstanding, and in this particular batch, this is the one that the program manager is screaming about, I need to jam into the schedule today. What we can do is, with a simple drag and drop environment, we can drag these individual sections or discrete portions of this job, in this case all of the surface mount work that needs to be performed first. And just by dragging that section of that job onto my schedule, I have immediately and automatically calculated the amount of time that that's going to take. You can see that's going to bring me into approximately 11:30, 11:45 on Wednesday. And the color coding that you see here in that beige means that this is now scheduled, and my materials, all of them, are reserved. 60 of 60 parts were reserved for that portion of that work order or that batch. If I do the same exact thing for the next section of this work order and drag the through-hole portions, the color coding is different. You see a gray bar, and you see the notation down here at the bottom. 11 of 12 parts were successfully reserved, meaning that I am missing some parts. There are parts that are, for one reason or another, unavailable to me for this particular work order. Now, the beautiful thing about FactoryLogix is that we can very immediately resolve and determine why these issues are occurring, and perhaps even have some solutions suggested to us. For example, if I double click on this entry for this missing part, you can see that I have two potential solutions. Number one, we have an alternate part number that was found. The bill of material for this particular work order is calling out this 14323CT. However, we have a viable alternate part number, 14323CU. And just by checking that box, I can then resolve this shortage by utilizing an alternative part with just a simple click. In addition, you can see that we have the part is found on an incoming purchase order. It was due onto the loading dock on Friday, July the 6th. So we have a little bit of a back order here from our vendor. Perhaps that's sitting on the loading dock, hasn't been brought in yet. So I have two different solutions to this potential problem. The near term and the adaptive planning is what we're after here. And finally, the assembly hierarchy is known to the system. So attempting to schedule a portion of this assembly prior to its subs being completed, the system will actually prevent you from doing so. So in this particular case, it's telling me that the wire and cable portion of this particular assembly cannot be scheduled prior to the surface mount portion of the assembly being completed first.
FactoryLogix incorporates a module that we call digital manufacturing engineering. This, in many cases, would be called the new product introduction section of the system, as essentially that is what it does. But we find it important to differentiate from what PLM and the R&D platforms consider new product introduction. And this actually, in a way, will explain where the DME module fits into the manufacturing world. When the customer's R&D group or your own R&D group go through the process of getting a design ready to go to production, they call that new product introduction. Getting the CAD done, the prints, the bill of materials, getting that into all under revision control, and everything that defines the product is NPI to them. However, those in manufacturing know that even when a perfect NPI from R&D is complete and handed over to the factory, you can't go to production with that. That's not adequate to start building the product. There's an awful lot of work has to be done from that point forward to take the design and the BOM and make what's often called the manufacturing work package, which includes the quality plan, the route and the process the product will go through, the logic decisions, the look of all the visual work instructions at every station that the operators would need, the entire support of the manufacturing process and its operators and the machines. Everything that's required is a great deal of work to build that, and that creates a work gap from what R&D considers released to production and what actually can be released to production. And that's where the FactoryLogix digital manufacturing engineering module comes in. It's a relatively unique module in the MES world in that there's an entire engine in the system used by manufacturing engineering to rapidly and fail-safe convert bills of materials and CAD from R&D into everything needed for production. But beyond the act of developing all the visual aids and designing the production plan and so forth, in the factory logic system, there are two levels of control that wrap around all of those processes I described. One involves the fact that we have a concept of a process revision in addition to taking the product revision that comes from R&D. So we control not only what you're building, which is the purview of R&D. They define the revision of the version of the product itself, and then we simply inherit that. But what if you build the product a different way? It remains Rev D for 2 years, and you build it 10 different ways as you figured out, I want to use a different line, or I don't want to use a hand assembly line, I'm going to automate that now. The Factory Logics engine allows you to actually have process revisions that allow you to have traceability and visibility to the fact that you built the product differently year after year, but you never necessarily change the revision of the design. Now, in addition to that blanket of control, we have something completely unique, which is called our Task Flow Manager. We learned that there are two challenges typically not always large, but manufacturing engineering groups have in handling their work. One is manufacturing engineers often go about the task of developing a work package differently. They add artistic license to the way they document things for the floor and so forth. So there's inconsistency on the work product from the manufacturing engineering lab. That's one challenge. The other challenge is that in large engineering groups, program managers, manufacturing engineering managers, they literally have trouble determining how far along are people in the work on the way to getting something released to production. Who's working on what right now? Are we close to releasing to the floor? How do we answer the customer as to when we are going to release? The Task Flow Manager solves both those challenges. It's basically analytics for the manufacturing engineering office, showing who's working on what, how far along are they. But also it provides a framework of essentially almost like a wizard process to send manufacturing engineering down the best practice task plan to get a full work package done, which brings consistency to the work packages that are going to the floor. And all of this is firewalled from the factory through electronic approvals. So nothing that didn't go through approvals can possibly launch to production. So what you're about to see is the engine that would be used by manufacturing engineering in the office to develop a work package. Now this is the interface here, the DME interface. And first, as mentioned, the process revision that's subordinate to the design revision is shown graphically in the tree. So this typically would grow to be a very large tree. The process revision is what defines how the product's built, and what's being built comes from R&D, and in this case is Rev D. So that's the first thing we wanted to show. But going into one of the process revisions, what you're seeing now is something that is used seldom, but by manufacturing engineering. It's sort of a setup portion of the system. But what you're looking at, both in the graphical rendering of this flowchart and the tree at the left, is the Factory Logic's process modeling system. That flowchart is not just a picture. It's actually dictating the algorithm and the logic that would be activated on the floor as production was running. So if one of those processes is dragged to another location, it will automatically update the sequence. If multiple stations are selected and an attribute like any order is set, it will actually show that, well, these two processes can be done in any order. They're not sequentially dependent upon each other. So, and also further, if we look at the red arrows at some of those inspection points, that's an abnormal exit condition. So if you click on that, the engineer could actually design an entire other flow, which then itself could have logic in it. So extremely complicated and comprehensive logic flows through processes can be engineered completely graphically. And these become templates that are then applied to different projects in the future. However, I want to note something that Aegis at least believes is probably the most important technical achievement of the Factory Logic's design, and one that we do not believe exists in any other MES offering. And it is actually graphically manifest here before you in this view. Most who are observing this to this point probably thought this was a routing across assets and stations and lines in the factory. But in fact, it is not. What it is a process model. FactoryLogic's design is a result of us realizing with our prior generation product that was in the field for 15 years that if an MES system makes a one-to-one relationship between the process and the physical world, meaning the assets, the machines, the routing itself, and then you link that one-to-one with the process that the product has to go through to become complete, you lose flexibility and any hope of things like emergency line switching to another line mid-production, configure to order, that adaptively adjusts a process across different locations and routes in the factory in order to accommodate an emergency change or an individual single piece flow, and many other things in terms of the ability to take a product being built in factory A and to transfer it to factory B with a totally different asset complement and immediately go back out to production. None of these things are possible if you have an affinity of asset to process, because it locks you into a certain configuration. FactoryLogix does not suffer from that. What you're looking at is the process flow, as I mentioned. The act of planning a job is what applies, and the product. So you take the product, the process model, and the act of planning, and those three things merge together to go to production in a given factory or a given set of lines at that time. So everything comes together only at the time it needs to be produced. That makes FactoryLogix unprecedentedly flexible and adaptable to anything that could possibly, factories, different products, different assets, and all sorts of emergency conditions. So as mentioned, this is done one time or very seldom, the setup of the process. But what would the manufacturing engineers actually be using when they're building the work package, so to speak, the visuals that would be built for the floor? And that's what we're looking at right now. You might recall this view from our former demonstration of the MES portal. Well, what we're looking at right now is what was used to build that. It's a graphical construction environment where you have all manner. You can see at the ribbon at the top. You see all sorts of graphical tools, arrows, eyeball views, shading, and just what you would generally expect in a graphical editing tool. But you also have the ability to insert text, rich text, or smart text. Those are text fields that are, as I mentioned before, drawn from our database. So that drawing header down there, that's a collection of rectangles and text, the text entries are actually smart text that is looking to the database to auto-populate its content. The manufacturing engineers can also preview what the user interface would look like for the operator on the floor from here. So they can build very rich interactive instructions through this environment and then apply them to different process stations along the routing. Now, as I mentioned in the introductory slide for this digital manufacturing engineering interface, there's the task flow system that's used to monitor and track and guide what's going on in a manufacturing engineering group. And this is the interface that we see there, where that's actually basically the scheduling of the tasks across people, who has to do what in order to get that work package out to the floor. But it also has an entire analytical engine, which you see here. So manufacturing engineering management can literally see the utilization of the engineers, who's overloaded, who's underloaded in terms of getting things done, what's the on-time performance, how close are we to getting something launched to production. So it becomes an entire engine to really know, without having to go around and ask people, know what is going on in all the work to get engineering changes out, deviations, and initial product launches out to the floor. Now we come to the FactoryLogix support of RMA and manufacturing repair and overhaul. And we can't demonstrate this in the time allotted, but conceptually, this actually links back to what I was talking about previously about the very unique design structure of FactoryLogix where it does not, the process is abstracted from the physical assets in production, which that it is actually why the ability to handle MRO in particular and configured order is so elegant within FactoryLogix, because normal production is easy to model. You have a route, you have a flow through it, you're dictating what assets it's going through. It's a very simple model. But things become a lot more complicated when you have a product coming back for repair and you don't actually know what the route needs to be because you have to diagnose it and repair it and get it back out in the field. So the route is ad hoc or just in time, as we say. FactoryLogix literally lets you build a route in production on the fly in order to execute an RMA. Or you have an MRO environment where the product has to be torn down to a certain configuration, which pushes it through a very unique route in order to determine what level it's at and then take it back up to a different rev before shipment back out. This involves not only route changes, but discovery along the way and adaptability to the variables as they're being discovered that impacts both the process and the BOM content. FactoryLogix fundamentally handles that as well. And then the final element is CTO, where you're building what could be single piece flow, where there's so many product permutations and with options and internationalization or whatever it happens to be, the ERP system sends down a unique iteration of that product. And FactoryLogix can literally not only permutate the BOM to accommodate the configuration that ERP said for that one piece, but then change the entire process flow, the visuals presented to the operators automatically without human intervention. So you have an environment where it is a truly adaptable process that goes beyond anything possible with a traditional system that basically is just the top, where it is one-to-one, this is the asset flow, this is the route, and this is the process. With FactoryLogix, you're not limited in that way. The final solution area we're going to cover in FactoryLogix involves manufacturing intelligence, the components of the solution that were built natively within FactoryLogix for the purpose of enabling anyone in the factory to get the information that they need from the system and turn it into insight. So rather than requiring the assistance of highly skilled software engineers, people with SQL expertise, or the IT department and burdening them, the engineers, the quality people, whomever, can get the outputs that they need themselves. And in order, this system is comprised of a few main areas. The first is reporting and charting, the ability to generate PDF reports or dump data that was mined from the system into Excel, into a directory, and so forth, the traditional type of functionalities that most would associate with a business analytics system. But in addition to that, there is a mobile interface called Insight that allows anybody with an Android or iOS device to get the information, basic information out immediately as they're walking around with their mobile device. And also, we have real-time dashboards. So, and when we say real-time, it is literally such that if there are dashboards displaying, for example, the state of a machine in production and someone opens a hood, the moment the hood is opened, the gauges and indicators in the dashboard will update. So they're truly real-time, but they too are also configurable by the end user. Another area is what we call digital KPI corkboards. This area is almost every factory you walk into around the world. When you go down the hall on the way to the main doors, there's usually some kind of a panel or a section of the wall that's covered in paper KPI reports, Pareto's, yield the last month, WIP information, so forth. We have a means of digitizing all of that on flat panels. So basically everything that's taking all that labor and manually intensive to generate that needs to only update maybe every day or every hour or something like that, we can digitize them, and there are digital KPI corkboards. And then the final and probably most diagnostically important element of the manufacturing intelligence suite we have is our data miner that enables not just reporting, but the interaction of multiple people to interrogate, drill into, not modify the data, but to change the way you're approaching and visualizing the data in real time with one another in order to get to the bottom of a problem. So in order to illustrate how all of this would become real and useful in your manufacturing enterprise, we came up with a scenario that we'd like to take you through that illustrates the main elements of this using a real-world possible situation. So to begin, I'd like you to imagine a manufacturing engineer is in an electronics manufacturing factory, maybe Rapid Circuits that we talked about earlier, and is having lunch in the cafeteria. The FactoryLogix active rules engine was configured by quality, or maybe by this engineer himself, that when his customer's yield dropped below a certain point, he would get an automatic email. So he's sitting at lunch and he gets his phone buzzes and he gets an email and it says a human readable email comes that's context automatically generated based on context, and it says the yield is dropped on your customer for this product line and so forth. So he puts a sandwich down and he grabs his iPhone. And on the iPhone, he brings up the Insight app that you see here, which allows him to drill into various key parameters related to quality, the WIP tracking information. So he looks and he sees that there actually is a problem, but then he goes to see where that customer's product is being built because he doesn't know what line it's on right now. So he goes to the WIP tracking information and it shows him that. And he abandons his sandwich and he goes out onto the lines and he heads for that line. Now above that production line where his products are being built, there are real-time dashboards on large LED displays hanging above the line. And this is an example of one of them. And he looks up, and these are changing in real time, and they reveal that yes, in fact, there is a yield problem going on, but it doesn't give him enough information to really find out the root of the problem or its scope. So at this point, he decides he needs another capability in the FactoryLogix system, which is that data miner I mentioned. So he contacts some quality people, a couple other engineers, asks them to go to a conference room with a projector. And up on the screen, this tool, which we call our data miner, comes up. At the left is the toolbox of all the data generators available to them with subsets. So it spans things like quality and test, even new product introduction status, materials traceability, WIP, active WIP visibility, and where production actually is, and so forth. So this is a quality issue that we're talking about. Yield has dropped. So he hits a template generator that he had for yield and quality and Pareto related information before, and this comes up. And you can see at the right the hierarchy of the drill down that's available, and as he clicks on the bars, it goes further into the data. Okay, that's the customer, this is the unit, the defect types, and so forth. But it's still not enough. So what can you do? At this point, this is your chart. Well, no, not in Data Miner. Data Miner was designed, you have all those people in the room, and they're saying, well, you know what we need to do? We now need to know the work orders so we can see if it's limited to a work order or more severe in a work order, and see if it's an operator-related thing, so drop that in there. And you go back to the chart, and you'll notice that the drill down has completely changed at the right. So traversing the data now cuts the data differently and reveals entirely different things. So now we see, yes, actually there is one work order for that customer that is the offending work order. And then when you drill into it, you see that a certain operator may be a problem for this. And you can keep going back and forth and changing the drill down to look at this data anyway. Now we only took one relatively basic quality type diagnostic. As mentioned, that toolbox at the left, every single one of those many, many data generators, you can apply the same methodology to it. Drag and drop, interrogate the data, drill into it, and then of course say this was the view that revealed the root problem and something that needed to be addressed by others. It can be immediately snapped to a chart in PDF form and emailed out through the rules engine or simply manually. So as we've seen here, the act of interactive interrogation and diagnostic of the data is simple, not requiring any special IT skills, and snapping to the report. But what we've not looked at, we did see that dashboard that he was looking at above the line. Now let's go over to how that dashboard came to be. It's similar in principle to what you saw with Dataminr. This was the dashboard that was running, but on the floor, but this is the user environment that was used by the engineer to make that dashboard. So if we look at this yield gauge here that was just highlighted, we're going to delete that gauge in order to demonstrate how it was actually created in the first place. You have your toolbox of all sorts of different indicators, gauges, charts that can be dropped into any dashboard. Now notice what it did. When that gauge was put in, there was an exclamation warning icon came up. What it's saying is, I don't know from where to draw the real-time data stream for this thing you just put in this dashboard. So it popped this dialog up. Now what you're seeing there is drawn from the backbone of FactoryLogix, which is the asset list, the actual machines, sensors, devices that the IoT data streams are coming into the back end from. So all one need do is click on the actual asset human readable name that was given to that sensor or machine. In this case, it's an inspection machine. And by doing only that, a huge technological achievement occurred in the background that the operator need not worry about, the engineer need not worry. It just connected that gauge to a real-time data stream coming in from an IoT adapter to a machine on the floor, and if he runs this, the real-time preview, it will actually be getting real-time data from the floor. It is that simple to do anything in an iMonitor dashboard designer. However, there's more to this. In many cases, if you're using a dashboard on your desktop in your office or something, you might want to get more from a dashboard than just looking at this one that we have here on the screen. So what if you want a situation where you have a line level view, but then you want to be able to click on a machine and drill into more detail for that one machine, and then, like a website, keep going down the navigational? Well, how would you do that? With iMonitor Designer, it actually is done very much like a website, where any entity, any one of these gauges or indicators in this view can be hyperlinked to any other dashboard. So you can literally make an entire real-time website, effectively, of your dashboards, of your own design, and then put them against your user profile and have them available anywhere you want. So in summary, we took you through the scenario and also how unique it is that because FactoryLogix manufacturing intelligence system is aware of the data model, aware of all the real-time event streams, the architecture supports the IoT plugins, it is exceedingly easy to get any report, chart, diagnostic, real-time dashboard that you could possibly want out of the system without any particular software skills whatsoever or knowledge of the database, which makes it puts the power to get analytics and reports and insight out of the system in the hands of the people who actually want to do it, while freeing up the folks in IT that perhaps their efforts could be better spent elsewhere.